So hello everyone. So as you all know that one of the major concept that we call as concavity that was left in my previous video. So I will be discussing about the concavity in this video. Okay. So let's begin from here. Now, if we talk about the concavity, so there are two kinds of concavity. One is concave up and second is concave down. Concave up and concave down. So a lot of students have the confusion whether the graph of the function is concave up or concave down. Sometimes they say if the graph is actually concave up, they generally say that it is concave down, and similarly it's converse. So I will be just clearing the concept and clearing the difference between the concave up and concave down in this video. Okay. So now concave up, if you talk about the concave up, so let's make the x and y axis here first. Okay. So concave up is this and concave down is this. Now how you will differentiate between these? Because sometimes what happens that it would be in the negative or fourth quadrant. This is the fourth quadrant. This is the fourth quadrant. So sometimes what happens, generally students face to tell whether it is concave up in the fourth quadrant and whether it is concave down in the fourth quadrant. They have a confusion regarding all the quadrants. So I am just generalizing that confusion, and I am generalizing that confusion in a generalized approach, which is a fundamental approach of that slope of the tangent. Now see how I have made this approach. So this is a very unique approach. I have just made it on my own for the better understanding of the students. So suppose if I want to know the the slope of this point, okay, this point is suppose A, and I want to have the slope of this point. So as I have already told the concept of slope in my video of what is dy over dx, so you can recall that concept from that video and implement that here. So here if I say what is the slope at this point A, then you will make the tangent and you will measure the value of tan theta, or you will measure the value of y by x. This is y and this is x. So this is basically the slope of line y by x or tan theta. This is theta. Okay. You can recall this concept again in a more deeper way. If you want to go in this concept, then you can recall it from that video. Now if I want to have the value of slope over this point, then it is this way. Okay, this theta will increase. Again, if I wanted to have the value of dy over dx in this, again the theta will increase. So what you see, theta is increasing. That means tan theta is increasing. That means the slope of the graph is increasing as we move towards the right x-axis. As we move towards the positive x-axis, okay, then the value of the slope of every point that belongs to x-axis is increasing. Okay, so if this is happening, then we call it as concave up. So in concave up, what is happening? The slope of the graph is increasing. The slope of graph is increasing. Slope of the graph is increasing in concave up. And if we talk about its converse, then in this case the slope of the graph would be decreasing as we move towards the positive x-axis. This is the positive x-axis. If you move, then suppose this is the point A, this is the point B, this is the point C. So both the functions are increasing. You can see here both the functions are increasing. The values of y-axis is increasing with respect to x, but the slope of the increasing function decides whether the concavity is up or concavity is down. So the deciding factor is slope. So here, if I take the slope, then I am making a tangent, I am taking a slope. This will be theta. Similarly here, I am making a tangent and I am making a slope. This is theta, and here again. So this would be very less, right? So you can see the value of theta is decreasing with respect to the positive axis, and therefore the slope is decreasing and hence concave down. So you can apply this concept on any of the quadrants, a similar concept on any of the quadrants, right? And you can just assess whether the concavity is up or concavity is down. So this is a major concept of concavity. Now I will just give you one example to verify this concept. So suppose I am discussing the same function y equal to ex that I have discussed in my previous video. Now I want to make the graph of ex, right? So how I will make it? Suppose this is the x-axis, this is the y-axis, okay? And I want to make the graph of this ex. So from the previous concept, if the slope is increasing, right? If the slope is increasing, so how would we calculate the slope of the increasing function? So the slope of the increasing function or decreasing function is calculated on the basis of this factor. This is the factor which will decide whether the slope is decreasing or increasing. If you will calculate the value of d2y over dx square, okay, then if it is greater than 0, then concave up, right? And if it is less than 0, this factor is less than 0, then concave down. I have already told the concept of what is concave up and concave down, but in the case of functions, you have to calculate the value of d square y over dx square, and you have to check whether it is greater than 0 or less than 0, okay, at any point, and accordingly you can analyze whether the function is concave up or concave down, okay? So now I am just calculating the value of d2y over dx square in the case of y equal to ex, okay? So when I will calculate the value of dy over dx, then it's ex, it's same, dy over dx. Again I will calculate the value of dy over dx square, then again it's same. So as you all know that the differentiation of the e to over x is same, and if you say that d3y over dx cube, you will again differentiate this, then also again e to power x. So it will never change. This is the formula. So now if I say in the positive x-axis, first we take what is the value of y when we put x equal to 0. So at x equal to 0, y equal to e to the power 0 equal to 1. That means this is the point where this function would exist, okay? At y equal to 0, this is the origin, sorry, at x equal to 0, this is the origin, y equal to 1. Now dy over dx equal to ex. Now for all the values of x, okay, whether they are negative or whether they are positive, right, this would be greater than 0. That means we know that the dy over dx value is greater than 0, and hence the function is increasing. So the function is increasing for all the value of x. It would be something like that or that. I don't know about the concavity right now because I am seeing only dy over dx. Now I will see the concavity, which can be assessed with the help of d square y over dx square, and this is also greater than 0 for all the value of x because ex and dx are same. So dy over dx is greater than 0, that means it is increasing. This function would be increasing. D square over dx square is also greater than 0, that means it is concave up. Concavity is up. Now I can make the function. So this would be increasing, and how it is increasing? It is concavity is up. So this is the function would be going like this, Okay, if you come towards the negative axis, then also it will be increasing in the negative axis. So you can make like this. So this is the concavity. The slope is increasing. You can see here. So you can make any function by checking dy over dx and d2y over dx square. You can check anything. D2y over dx square is simply the again the differentiation of dy over dx. So that's all from my side, and I hope this concavity concept is very much clear. And if again there is confusion in anything in terms in this topic, then please ask me in the comment section. Thank you so much.